Cool. How's it going, guys? React Week, some ups and downs, but I think it'll be nice in the end. Originally, this lecture was supposed to be complex state management and WebSockets. The WebSockets part of it kind of got axed just because all the WebSocket work that you guys would be doing with Scheduler has kind of been pushed to stretch because it was maybe a bit ambitious. That being said, I did put together a real nice WebSocket part of this lecture, so we'll maybe demo that at the end if we have time, and we'll see. I think part of this lecture can also be maybe like a choose your own adventure, because we're going to be trying to go pretty in depth into complex state management, or specifically reducers. But if we're feeling confident with reducers, then we can kind of jump in and maybe look at either some WebSocket stuff, or we can review some of the React things which you guys would find helpful looking back into. It kind of depends. But yeah, we'll test the waters as we go, and we'll see what everyone's feeling maybe around halfway or something. So our topics, we're going to be looking at reducers. This is going to be our main way to handle more complex state within our React components. We're going to look at what pure functions are, static and type reducers, and then we're going to look at the reducer hook itself. This is a bunch of stuff, again, on WebSockets that we'll probably glance at, but I'll give you the notes regardless. So if it's something you're interested in, you can kind of dive deeper in the notes, and there's a couple of links in there that you can explore as well. So starting with reducers, I guess, like, what is a reducer? In a more general sense, a reducer is just a programming pattern to reduce data structures downwards, or to take a group of data and, given an action, kind of synthesize that into some new data. It's a general pattern, and it's something that you've probably even used without knowing it. For example, if we go in here, if you guys were given maybe an array and had a bunch of values in it, and someone told you, I want you to take this array and I want you to get like the total sum of all the values. Your approach might be to like make a loop, and as you're going through that loop, maybe you have a tally number. Starts with 0. And as you go through, this is familiar to everyone, we just get the total of each value from the array, and at the end we can just console log total. And this right here is, in its simplest form, like a reducer pattern. If I bring up terminal, have to go a bit deeper. What are we? Week 7, day 4. And rerun this guy. We're going to get 10. So we've reduced this more complex data structure down into like a single value. When you guys have done this in the past, that's like reducing. That's your own homemade reducer. JavaScript itself has a native reducer built into it with arrays specifically. And that's also something you may or may not have used. But it does kind of that for loop and tally kind of built into it. So we can do array.reduce. And this is a function built into arrays that takes a callback. And this callback takes 2 parameters. An accumulator, it's called, and the value. So the accumulator is kind of what acts similar to our total in the for loop that we had before this. And the value represents our current thing in the array in turn. So value will, for the first loop of this reducer, be 1. For the second loop of this reducer, be 2, and so on and so forth until we've reached all of the elements of our array. And what we do is this function itself should return the updated accumulator value. So what that means is if I go return accumulator plus value. And we run this. Oh, yeah. So we'll throw in our second parameter of reduce, which is our initializing value. And we run this guy. Oop, something else. Total is not defined. Oh. We want total now, instead of to be nothing, to be the result of our reducer. So we get 10. Accumulator, again, acting as a total. Actually, I think, in fact, we don't need the initialized value, because if we go, it'll still work. By default, it's going to be your first value in the array. So if we come in here, if we come in here and we just do a console log of each accumulator, we're going to see that as we run this, it starts at 1, the first value, and it even skips that that iteration of the loop. It just says, okay, we assume that you're going to be adding this. We'll go 1, 3, 6, and then 10. This is similar to our sum one, but this callback that we're passing to reduce can be used in a lot of different ways. We're reducing it to a sum. We could do many things that we want with this value in different ways. In fact, we're going to get kind of creative in how we do this reduce function, as we'll see in a second. So just a basic reduce that we saw. Yeah, I did get rid of it, so.
I can do it on my own.
What were you wondering?
I was so it's looping through the whole thing. So it did do the console log every time the one inside.
Well, we would have seen, I think, only 3 console logs. Yeah, let's run it again. So I should have kept it open anyways. Week 7, day 4. So these are the 3 console logs. Like if we went inside, even though we have 4 numbers, we only get 3 loops because it's skipping the first one because we didn't initialize the first value.
And then if you initialize, then it would have done that.
Yeah, let's do a 0. So now we get the 4 because we've initialized. Kind of for better or worse, depending on the behavior that we wanted. So get out of here. So that's the built-in reduce pattern with arrays. The one thing to think about with this pattern, or even with our for loop, is that this is what's known as like a pure function. Have you guys seen pure functions before, or looked at the concept? It's not overly complex. All it means is that the output of this function can be determined by exactly its inputs. There's no external factors that are going to influence what the values, or in this case, like what our console logs or our total is. As long as I give it this array, this reduce will produce the same results every single time, no matter where it's used in any program, no matter how many times I do it. This is like a pure function. It doesn't rely on any external variables or like requests or asynchronous things. It's consistent with just what you get in equals what you get out based on some way. This allows this function, this type of function, to be very predictable and to be used in like consistent ways. We can also add complexity to our reducer. So this is like very basic and probably not that helpful. I mean, maybe we want to sum or subtract a big grouping of values. But we can nest objects by using this same pattern. So we're still using it on an array, but instead we pass each value of this array being an object that gives us additional information on how we use the reducer. So let's maybe just jump into the example instead. So we have this array. If we don't want to just sum all of these values, but instead we want to do like adding sometimes, subtracting other times, maybe even like resetting the total, what we can do is we can pass an array of objects. And for the object, we're going to give a type, which will tell how the action should be executed. So we could say add, for example, and then we'd also still give a value. So our value might still be 1. And then second, we could say this type we want to subtract. And then our value, we could choose 5. We could have another one. Maybe we go add again. And then even at the end, if we wanted to, we could do like multiply. So the key thing to think about here is that we've added complexity to our array or our set of data. That doesn't mean that reduce is going to just handle that complexity by itself. We're just going to take the kind of already defined callback and make it work to use our new data. So we have accumulator, which will be our running tally, and we have value. Value will now represent, say, first this object, then this object, and so on and so forth. And what we can do is we can create maybe a set of if, or we could even use a switch statement to check what type the current value is, and then do the corresponding actions. What might be a better way to call this value is to call it an action. Because it's a parameter for our callback, we can name it whatever we want. And we can check if the action.type equals add, then there's something that we want to do. Else, if the action.type equals subtract, then there's also something we want to do. If action.type equals multiply. And then lastly, we might just have a default. Yeah.
Sorry to interrupt. I need the other dongle.
Yeah. I got dongles for days, man.
Got an HDMI to Mac one?
This one's a bunch. Yeah, give them a couple.
Okay, these are dongles.
So now we have our accumulator checking the type of each of these objects, and then we can conditionally like do act upon the accumulator depending on what the type is. So again, our behavior of this callback is that we want to have it returning the new value of the accumulator. So if the type is add, we still want to do a return, and we want to do accumulator plus the action, but not the whole action, because the action is just an object right now. We want to do action.value. And then similarly, we can just kind of copy this line for subtract. We want to return accumulator, but we want to minus the value now. And for this one, we want to times the value. And then maybe the default, if they didn't specify a real action, we can just return the accumulator, so we don't do anything. So now if we run our test, we get -2. It might be nice to keep that log of the accumulator so we can see how it's acting upon our data. So we start with 0, which is our initialized value. And then our first action is add, and we add 1, so we get 1. Our second action is subtract 5, so we get -4. Then we're going to add 3, so we get -1. And then lastly, we're multiplying by 2, so we get -2. What happens here is that we can get a bunch of useful behavior from one function, and we can conditionally, based on our data, create different patterns to act upon this singular accumulator thing. So this is maybe more useful, and we can build up sets of actions that we can do on a single set of data, or maybe we can conditionally add more actions to our array. There's different uses here, but by itself, this pattern maybe isn't speaking to you guys. It might not be the most interesting thing. Where it becomes actually powerful is when we look at it in the context of React. So you guys have up to this point been using useState, and state is a set of data that you apply actions or you apply behavior to. If we look at our pattern here, it might start to seem like there could be a connection between our set of data here, and so our data in this case is just like a single number, and we're doing different actions upon it and getting the reduced total, or the reduced total might not be the best, well, yeah, total still works, value from it. Another hook that you can use to manage state in React is useReducer. And it's named reducer because it's modeled after this built-in array reducer. But it allows us to perform actions or to compile data on our state, or to act that way on our state. Similar to our reducer here, useReducer within React takes 2 parameters. A reducer function, which will look maybe very similar to this. And then it also takes an initial value for that state. So the same as useState, when you say useState, you pass it maybe 0 if you're starting with a counter, or you pass an object that maybe represents a user, and that's what it will initially be set to. With useReducer, it's the same thing. And then the useReducer returns, again, two parameters, or outputs 2 things in an array similar to setState. One is the current value of the state, and the other is a function for updating the reduced state, or the reducer state. Let's actually look at a demo again, because I think it's easier to see it in action. Yeah.
Considered
A factor?
a factory.
A factory.
Because it's taking in, it is taking in objects.
Mm-hmm.
It's outputting objects technically. And it's modifying depending on what's inside.
I don't think it's exactly the same as a factory function,
Yeah.
but it does have some overlap, and we'll look at it in a second. There's even more overlap with some of the ways that we can use reducers. Actually, maybe to on that note, we can start before we even jump into seeing the pattern in React. We can look at our reducer here, and we can think of, given our reducer function is this, what might be some better ways of optimizing this code, just based on what you guys know at this point. So what's an alternative to using a bunch of if-elses down the line?
Switches, but aren't switches technically immutable?
Yeah, so one option is to do a switch. We could do a big switch down here. The other option is something that's called a lookup. I don't know if you guys have seen that at this point, but that might be a little bit down the vein of what we're thinking. So if we go const lookup, A lookup is an object that has a bunch of, well, either values or functions that you can look up and use in other cases. So here, maybe you would say we have one key called add, and we're going to set that equal to a function. And that function will take in the accumulator and the action. Or maybe, yeah, it will take in a value. And then we can have other things that we want to look up or other actions. We can have add, we can have subtract. That takes in the same thing, accumulator and a value. And then finally, we'll do multiply, where we have accumulator and value. And now we can have each of these functions return accumulator, maybe plus value, accumulator minus value, and accumulator times value. Yeah. And then instead of having this kind of more messy switch thing, what we could do is we can say return the lookup, so we called it, of our action.type. And we want to pass it because it's a function. This is looking up from our object and returning, assuming one of these functions. So if this is returning a function, then we can call that function with using parentheses right after, and we can pass it the accumulator and the action.value. We can get rid of all of these guys here. Now we have a bit more elegant of a solution. We're going to use the lookup to find the action and then call that lookup function with the accumulator and value and then get the return. Our lookup now has three things, but down the road it's very easy to add more functions to our lookup and still have the same I think I'm just going to open a terminal here so we don't have to keep closing it, because it's not nice to have it all big when the slides are up. And we'll go node test.js, and predictably, we get the same result. But now we have a much cleaner kind of syntax. So our three options that we saw, this is a lookup. This pattern might be new to you. We could also use a big long string of if else. We could also use a switch. We kind of saw, or maybe you have seen in the past, some problems with maybe big long switches or big long if else statements. A lookup is kind of a nice way to get around both of those.
What if you don't have the action, no lookup?
So if you don't have the action and lookup, what you could do, so what will this function return? Or if I go lookup action type, and then I do this for nothing, for like an undefined value, what am I going to get? So let's do an example, I guess. If I go will you make up a new action? I give it just like a fake accumulator, a fake value right now. When I run this, Yet lookup divide is not a function. Yeah, exactly.
Then it would pull undefined, right?
Yeah, and then we're trying to run a function on undefined. What you can do is beforehand, where are we? Here. You could do like a if lookup. So you check if that's a thing, then do that. Else return like the accumulator.
So in the grand scheme of things, this is more integral for like maintaining and scalability of your code base, and then also being able to like utilize some functionality across multiple files potentially. So like you could have one file with 8 different kind of relevant things, and you can have one pipe in only using 4 of, another one using like 7 of.
Exactly. Like this lookup here could have functionality across multiple like components or multiple like reducers, and you could put it in a module and export it when needed. You could have similar lookup patterns for different states. So it really lends its way to reusability, and also, like you said, to like maintenance over time. If I want to add more things or edit stuff, I have a kind of like a single source for my lookup where I can just find and edit and modify without having to dig too much into my code.
But like in all honesty, like you're probably more likely to go to like Stack Overflow or like online than you are to utilize something that you yourself have implemented, right? Like this is good to be like talking about because this is what's going to be on Stack Overflow or whatever. But when it comes to it, you're more frequently going to be borrowing other people's code than you are going to be generating your own.
We will see in a sec. I think that is true for some cases, but your state, it often is going to be very unique to your project because your data might be very unique. And we'll see, I don't think it's too hard to come up with your own patterns. Yeah, we'll see some examples of that. For maybe more general things, like you're just dealing with like the UI of your page or like getting some animations, like common things that might be the case. But when we're specifically thinking about the data of your application, it's often going to be very unique. So let's look at this pattern with an actual like React component. So I don't know if this is, I'm going to try and make it a bit bigger. So this is just in Code Sandbox, the most basic of kind of React projects we can see. They've got an index somewhere, HTML page that just imports React and then has this root div. And then in our index JavaScript file, we see that we're rendering to that root div, and we have a single functional component called app that is just returning a bit of JSX with a wrapping div and a header and a h2 as well. So we're gonna start with the like classic bare bones React demo, and we're gonna do a counter, and we'll do it with reducers. So we're importing React from React. We also want to import use reducer, similar to how you would do use state. Same thing. You can keep both if you want, if you think you're going to be using both. In our app, we're going to get an array of 2 values. Again, very similar to how we would have used use state. Is this big enough for you guys back there? Yeah? And we're going to get a counter, or I guess the current count maybe. And we're going to get a function that we're going to call dispatch counter. This will be the result of calling use reducer, which, like we briefly mentioned earlier, takes in 2 parameters. One will be the reducer function that we end up using, so we'll call it count reducer. And then the second will be the initial state, so we'll start it as 0. We can define our reducer function up here outside of our component. Because it is a pure function, it will be called with some input and give the same output every time. It isn't dependent upon anything that happens inside this app component, so it's best for us to lift it outside of it. So we'll go const count reducer. This is going to be a function that will take the current state and an action, and then it'll do a set of actions on it. In our case, maybe we'll start with a single if statement, and we'll check if the action.type, if that's going to equal add, then this is exactly the same as the reducer we made before. We have a accumulator represented as the state of our application, and we have an action. And we're going to return, again, the new updated accumulator, but in this case, the accumulator is represented by our state. So if we want to add something to the current state, we're going to return state. In this case, we know our state is just a number, so we can just do state plus action, and we're going to assume that our action has both a value and a type. Down in here, we can, maybe we'll have the h1 just be the value of our counter, which is count. It starts at 0. And then instead of having an h2, we're going to have a couple buttons. We'll start off with an add button. And on click of this button, we want to call our dispatch counter. So there's a little bit of like passing the ball back and forth here. Our way of using our count reducer is through the dispatch counter. So we call the dispatch counter, and we pass it the action that we want to do. So in this case, we want to type add, and we want to add maybe just the value 1 to it. We are calling a function with custom parameters, so we need to put it inside of a wrapper function. And I'm getting all my brackets mixed up, so let me just double check. Oh, it's not my brackets, it's that I'm using bad spelling. So we'll go back and we'll just put in our use or dispatch count. So we want to call dispatch counter, and we want to give it that object that has both the type, which in this case we only have one right now, which is add, and the value, which will be 1. What dispatch counter is going to do is it's going to call the reducer with our given action, and it will take care of passing in the state, the current value of the state as well. It just makes it simpler for us. Instead of having to call count reducer and give it the state and the action ourselves, it knows that you're going to be using this reducer on this state, so it takes care of that for you. It's just a little bit of abstraction that allows us to only think about, well, my counter, I want to do this action. That's all you have to think about, and then you leave the reducer up to modifying the current state. So if we look over at our little component here and we hit add, we now have like our basic counter going through. Of course, we could have easily handled this with use state. And in general, like we're going to do another demo after this. We're going to try and get into a level of complexity that the reducer really starts to become useful. But this hook is really going to shine the more complex your state is, or the greater number of actions that you need to do on the state become. So with a simple counter, we don't have that amount of actions right now. So it's hard to see, I guess, its usefulness. But what we can do is we can duplicate this button, and maybe we add a subtract button. We add a reset button, and we change our types in our dispatcher, in our action, reset. And then further up in our reducer, we can now add a couple other cases. Else if action.type equals subtract. We want to turn state minus. And then lastly, if we have reset, then maybe we'll just return 0. Whatever we return here, use reducer handles updating that to the state. So we have our 3 little buttons. We can add, we can subtract, and we can also reset it back to 0. The one thing that will be nice, or I guess another thing about reducers that will be nice, so the big thing is that's going to make handling state, more complex state, easier for us. The second thing that I really like about reducers is it lets us think in terms of user actions. When we're using use state, you're thinking really more on a micro level on what is happening to the data. Here, when we get an on-click, we would have to think, OK, we need to take the current data and add 1 to it. But that's not how a user thinks when they're interacting with our little counter. They're thinking, I want to do an add action. I want to do a subtract action. I want to do a reset action. In building these actions as a reducer, we now get to define and think about the different actions or cases that a user will be happening, and then only within that case define kind of the more nitty-gritty of what happens to the state. Throughout the rest of our code, now we just have like actions, add, subtract. That's much more readable than taking the state and adding a value, maybe like right in line.
So like
Yeah.
I get everything that's going on here.
Yep.
The issue that I have is like the abstraction where we don't get to see the magic, like it's doing this sort of thing. So
Yeah.
the sequencing of the use reduce
Mm.
is it's pulling in the type or the add and the value, and it, on its own end, it has like the function that we had built earlier, basically, and then just pipes out the count and the dispatch count.
Yeah, so
And then in the situation where it was reset, it automatically gets given a neutral value without anything else. It's just going to set it to that one value. Like the 0, you had it set to 0.
yeah.
So if it's not given anything within its type, or okay, that's what we ended up doing, yeah, type, then it'll just basically go to that.
Yeah.
It'll set the count to 0.
Yeah. Yeah, it's like this, it's, like, what's that running event where they pass the baton
Yeah.
back and forth? It's kind of similar. So we're given this public interface called dispatch counter, and that's like kind of the person that we deal with. We go to dispatch counter and we give them like an action. We say, here, this is the thing that we want to do. Dispatch counter takes our action and kind of like runs away, hands it off to our count reducer, but then also gives them the current state. They're like, hey, the user, they want to do this thing. Here's their action. Also, I know you need this state. Our reducer, whatever we define as the reducer, does its thing, and then it kind of comes back to use reducer and returns the value and says like, okay, this is what happened, and use reducer finally in like the closure of everything sets the state to whatever was returned to him by that guy. It's okay for the video, I guess. Yeah. It's okay, I can just. Oh, thanks. I got one, thanks. So us as the user, we are like here. And there's kind of a barrier. We can think of it as like a till that we can only come up to this point. And we kind of present like this box that has like an action in it. Behind the till, like maybe this is like a bank. We've got like, it's like a banker's hat. I don't know, definitely not this. And this guy's like the dispatcher. So we give this guy our action, and then he like walks back here, and he gives both the action plus he himself has like the state to another person back here. This guy's got like a, yeah. And this is the reducer. He does his stuff, and then once he's done, he returns like the new state. Like a nice, a state will be like a ball, but the new state is nice and shiny. He returns that to the dispatcher, and then like the dispatcher, like I guess, gives that back to the user in the form of, like he just always has access to that, you know, like count variable or something. So you kind of get, yeah, like from our point of view, we only worry about the action, but React is doing like this magic of handling, you know, adding that action to the state and then getting the new state and like popping it back out to us. Yeah. How are you guys feeling? We can break now, or we can push ahead a little bit and break in another little bit. What's the feeling? Maybe we'll just do a brief summary. I think there's some summary in the note, and then we'll break. So we saw that use reducer allows us to modify and update our state in more complex and manageable ways. We define the state, but then we also define specific actions, like kind of narrowing down what us as a user of the component can do to the state. We have some options on how we create that reducer itself. Our pattern for like setting up the reducer is always going to look similar to this. But the reducer function that we're using can look different ways. We can have a reducer that is just a bunch of, I'm going to make this smaller so it fits, is a bunch of if-else statements just chained. We could do something like a switch. And lastly, we could also have a lookup. So our reducer function uses the lookup and returns the function called by the lookup. This is like another pattern that you can also use if you want. Remember you said like, what if the action doesn't exist in the lookup? If we use and not add, subtract, or reset, or rest it, If we use a new one, well, if we do an or, we can check whether or not that's an action and then only run or only return if this is like valid. Maybe we'll break now, but we can think about over the break, what are the advantages or disadvantages of each of these patterns? So whether we use if or else, whether we use a switch, or whether we use a lookup, let's think of what are the advantages and disadvantages, and also maybe what are the cases where we might want to use an if instead of a lookup. Because there are advantages and disadvantages to both, but like a lookup might be too much for some things, or an if else might be like overly long and complicated for other things. We'll come back at 11:05, and we'll get back at it then. Yeah. Yeah. Which part do you want to look at?
Just when you're calling dispatch counter.
Like the React stuff?
No, like the actual code. When you're calling dispatch counter, I just wanted to see what you passed.
Yeah,
Because
yeah.
you're just passing it out. What were we just working on?
On the
Fusion.
This is the like the counter thing?
Yeah, okay, sorry.
Yeah, that's here. Yeah.
Passing just one single, so then this thing, so it wants to take. Yeah.
The other thing, I guess maybe we could have started with a simpler thing, because we don't
was
need
thinking about this.
we don't need it to be like it doesn't. There's nothing about this dispatcher that says it has to be an object.
Oh yeah.
If I just passed in like add, but I defined here that my action instead of having
Action. Like we just.
I was just action,
Yeah.
and then in here I just went +1.
Because
Then I could simplify it.
we don't need state. Like we don't need tilt. It
No.
manages. So state is going to
Yeah.
come from count.
Yeah.
Sorry, which is there.
Well, initially at the very
Very, very,
beginning,
very
it'll be
beginning.
0, and then after that, it's internally it's kept track of by this like reducer that we set up.
So effectively, like state is now our tally, and count is our tally. Well, state and count are kind of linked in their tally.
They should always be the same.
Yeah.
Yeah.
And so that's our tally.
Mhm.
Give it some action, and then just tallies it up.
Mhm. Yeah. Exactly.
That makes sense.
And then like throughout our component, if we want, like in this case, count is just a single number.
Yeah.
We can just use this is our entry point to grabbing it. We don't have to care about
Oh.
any other place. We just grab it using count.
Okay.
I don't know
Oh,
why. Like I
Yeah.
this, but what I'm clearing at the at count
Mhm.
dispatch after the declaration. What is going into at that point?
It's a function
Okay, that's what I thought.
that use
that
reducer
comes from the
creates for us. Yeah, exactly. And it's the thing that does that. Like, it's a dispatcher in the sense that that's kind of what it's doing. It's like dispatching actions to other things and then returning the new state back.
You could do instead of let you could response, right?
Yeah,
Okay, so that doesn't matter.
yeah, because I think you guys went over it a bit yesterday, but like this whole function gets called
Yeah.
every time that like something changes in here. So if I const this up, even though count is changing, it's every time it's a new variable. So we're still good here. Yeah. Yeah, if you want to.
There's simply add extra. That's not based on the
Yeah, exactly. And it from what I understand, like the way you guys have been moving in the code, you're almost getting to like a similar part of this. Like you're you're defining a bunch of functions that you're calling that then modify the state. So this just kind of like helps you do that. Yeah, exactly. And all of like the patterns you were looking at yesterday, like the immutable data patterns, those are things that you'll be using in this like reducer once your state gets a little more complicated.
Like, I just want to kind of clarify my understanding.
Yeah.
It's more so it's immutable because once rendered, and the rendered version is still there, another version, the previously rendered one is still there, calling another one.
Yeah.
So then you're just using that one. That's why it's because you're never actually changing the actual thing. You're just you're creating a new one each time.
Yeah, exactly. And it's still there. Maybe if you kept a reference to it, but if there's no reference to it, it just gets thrown out.
So you need
Yeah. Yeah, exactly.
That's how cleanup.
my questions.
Mine was just about like cleanup then, because cleanup, that's what cleanup does, is it keeps that reference to it. Because cleanup is in that closure. So when it does it's the cleanup for that specific. So it doesn't have a reference to it, or so it's just the cleanup is self-contained in that rendered version of it. So that's one.
In terms of like the old state.
Mm-hmm.
Yeah. Well, that's not a React thing. Like JavaScript itself has cleanup, which is like the second a variable no longer can be grabbed by anything, it just like erases it from memory. So it's just like within our component, the old state, if we haven't saved it anywhere, like nothing can access it. So JavaScript is smart enough to just be like, oh, I'm throwing that out. But you could have a thing potentially, like think if you put like a global variable outside of your component, and every time you got like count, you popped it in the array, you would get all of the states over like time, and they would still be around in memory because you can still access them.
Okay.
But that would illustrate what you're saying, and that like each one is like a stone tablet of like what the state used to be. Yeah, I mean you can change it, but the thing is you shouldn't, because React won't know that you've changed it. Like if I go here and I take count itself, and I say count now equals count plus 1, it'll change, but React won't know it has changed, and that's the reason.
On the render. But well, it's not even the render, because the render would create a new one. So even if you're changing count, that doesn't do anything really. The count there is just, it's almost like it's hard coded.
Yeah.
It's just a variable. So it's the render that does the quote unquote magic of the state change.
Yeah,
not
exactly.
So much the count or dispatch count. Those are just almost.
Yeah, like if I change count, it'll re-render and then just overwrite count, and it doesn't know that I've changed it to maybe like 1 now, so it'll just write it back to 0 or what it was originally.
Can I have to version that part like
Yeah.
keep the
Yeah.
keep track of the.
Exactly. Exactly. Yeah.
My question was about like with that. What does
This or Redux?
that,
This,
like,
yeah. Like, to be
is it doing the
honest,
same thing?
like before, so hooks, I think you guys have seen, is like a relatively new thing in React. I guess before hooks, Redux was like very novel. With hooks and with like reducer hook, it's less of a like novel thing, I guess. To be honest, I haven't used Redux that much at all. I think Nima's used it more if you want to look in with him with it. But with reducers within React, it's kind of like not as important of a thing. It still adds more things beyond just like the reducer, but yeah.
But it was kind of solving the same.
It was kind of solving the same problem. And also, I think like that's where the reduce hook came from. Was kind of like, oh, Redux is like this good library that like exists. Let's bake that into React itself. Oh, really? That's pretty funny. Yeah. Yeah.
Since Eric or sorry, sorry.
Yeah.
State already set by it.
By the dispatch counter?
Not by the by the dispatch counter. Yes.
Mhm.
So when we pipe it in, this is going into action, whereas the state is dealt with by.
Yeah, exactly.
So it handles the state part, and then we.
Exactly. Yeah, that's a good way of thinking of it. Yeah.
So like it has state in this hand, and it takes in
Yeah.
action.
And then it gives both of them
It
to
gets both
the
of them
reducer.
there, but we don't have to worry about this.
Exactly.
It's hard because we've always and this is going from declarative, where we've always been told give them this and this, both the function, these two things, so I can mash it all.
Yeah.
Whereas we're no longer giving two items. We only need to give one because
Yeah.
it's really relevant.
Yeah, exactly. That's a good point, like the declarative versus imperativeness of it. Yeah. Like 4 or 5 minutes, yeah. How's lecture?
Nothing. Somebody stole the dog.
There's just like a pile of them here. I don't know why.
Like when you need them,
We should like
they're even labeled.
chain
Like, they
them.
have,
We
like,
should like chain them to the desk.
We should fit them with like.
Once you leave the classroom with it, you're just like
Put some like fast acting.
Well, what's the lecture on?
Servers in the real world. So I make it all about middleware.
Real world.
Just to dive into middleware and press route.
Do it like jump into it. Okay. So we left thinking about these different patterns we could use: if else, switch, lookup. Did anyone have any thoughts on what the benefits, pros and cons might be to using each one of these?
If when you have if else is fine in smaller doses, but when you get into like bigger like functions, I guess, then it gets pretty dicey. Switches, I think they are super clean, but they're immutable, and I've experienced situations where like they're kind of side effecty, like, and then the lookup I guess is verbose, like they're like they're good for scale, but if you're only doing a small like thing, then it's a little bit much. Like there's a lot of writing.
Yeah. No, all good points. You had someone else had something? No. Another thing with like switches is the syntax for on JavaScript on switches is not super strict for some reason. So like here you can do a case without a break. And if you're returning, that's fine because it'll stop the switch. But if we're not returning, you're gonna have a like weird behavior where it just starts like executing more than one of your cases. You can do curly brackets after your colon to separate each case. You can leave them omitted. One of the reasons I think people sometimes don't use switches a lot is the syntax is a little, it's not the nicest thing, and you can be inconsistent with your syntax in writing it, and JavaScript isn't going to punish you hard in terms of giving you syntax errors. It'll end up doing weird things. And then yeah, kind of the big difference between like using an if-else or using like a lookup for me is like the size. If I'm doing like 3 cases, an if-else maybe is like a very nice situation for me. If I'm coming up with more complex things, or maybe even mixing in functions and values. Like we could have a lookup where we just, like reset itself could just be a value. Reste. So there's different cases. How are we feeling overall with reducers so far? Let's give like one of these ones. Good? Cool. I'm gonna try and run through a more real-world example of using reducers. We'll see how the pacing goes. If I'm going too fast, tell me to slow down. But what we're gonna be doing is we're gonna be thinking about making a like login form. So we'll just get rid of kind of everything that we have in here so far. And we'll start with the form. Inside this form, we'll have a label. Our label first will be for email. And then we will have an input. Our type for our input is going to be, I'm going to do text instead of email, because when you do email, it makes you do the @ symbol every time, and just for quickly running through it, that's kind of annoying to me. So we got our email showing up there. I'm going to duplicate this, and instead of email, the second one we'll do password. Our type, we can do password for this one. And then we lastly want an input, which type is submit. And value is maybe going to be login. So now we have email, password, and login. We will first maybe handle the actions for each one of these. So when the form is submitted, we don't want it to do its normal behavior. We want to override that with a maybe login function, which we will define within our component here. This is a function. It takes the event from that onSubmit action, and it's going to do our login functionality. For right now, we're just going to go event.prevent default, so we don't get the page reloading. By default, when I hit login, it's trying to do a request to a new path. This will stop that. And then we can just console log, maybe login attempt. Now if we go boom, 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 we see a little login attempt. Ah. No. There you go. So now we have to start thinking about kind of the state of our application. So with the basic login form, there's a lot of things that we could end up having for state. Maybe the first thing that we'll have is we'll go username and set username. And we're going to be approaching this login form from the lens of like use state. How have we been doing it so far? And then we're going to transition into use reducer once we kind of have it built out, and we'll see what the benefit or like what the comparison is between the two of them. So username, we'll start off with nothing. We'll also get the password, which we will, again, use state and initialize it as nothing. And we want to be able to get the username and password when the person types it into these fields. So we're going to bind the username and password to the input itself. So if we do value equals, this is email. Oh, username. It's not username, we want email. So we'll change this email and set email. And then same with password. We'll go value equals password. So now our values are stored, are linked to whatever is in this field. But if I try and type now, I don't get anything because I've just hard-coded the value to be email, which is nothing, and the password, which is also nothing. So what we can then do is add two new listeners. So on change, which is going to be triggered anytime this form is attempted to be altered. And on a change, we'll call an inline function that takes the event and then calls set email, and it passes the new value for set email to be, which should be the event.target value. So now if I type in email, I get the change, and it's also updating the current state of the email. Let's look at that a little bit closer. So on the change, this function will be called. The function takes in a single parameter, the event. So part of this event has access to the target or the thing that the event is occurring on. So when I do event.target, I am referring to this input box itself. And when I do event.target.value, it's the contents of that input box. So I'm saying when there's a change, call this function, use my set email, which is from my set state hook, and update the state to be the new thing that I'm typing in so that my state email is now responsive to what I'm typing in. Yeah.
Like I understand how this works, but like this is the depth of how this works. Because it's not paradoxical because you hard code values to a certain state. However, on change, it updates that same thing that you hard code, so you don't know it.
Yeah. It's like cyclical, which seems like it wouldn't work. The one thing from my understanding is that this event, like naturally when I type, say I just type in the letter A, it triggers an on-change event, which is trying to set the current inbox thing to whatever letter I set. If I don't have this, it tries to set it, but it is already set to a value, so it just keeps it blank. When I do this itself, the event still gets triggered and the event still has that value, but now I'm force writing it to email so that we get an update in the state and we get the whole thing re-rendered with my new value. Yeah.
So it is hard coded. It's just that the A is a different function than the guy.
Yeah.
Oh, so okay. The question I was about to ask is this on change event is happening every letter,
Yeah.
and so it's being re-rendered every
Yeah.
time.
So
And
we
every time we're getting a new state updated every time.
exactly.
At the end of the day, the value is residual there.
Yeah. So set email is being triggered every letter press, and it is updating the state itself.
Every time.
And then once we update the state, that triggers our re-render, and our new state will persist through our re-render,
But the
and we'll get
re-render is only happening
the value.
That's the other thing.
Yeah, so we go. So we can copy this same on change. And then we'll add the same thing with password, but instead of event or set email, we'll do set password. And now we can do email and password. And we also, because we've set these two values as part of our state, we have access to them throughout our component. So when we do login attempt, we can also get the email and the password. Yes. Yeah, so you'll have a re-rendering of the component. To be honest, I'll have to look a bit more into it, because when we use class components, part of it was that React is smart enough that it has this idea of a virtual DOM. And so it checks, like, you've just changed email, what elements of this component are affected by that. So in this case,
That it only, like it by itself will figure out what actually needs to be done.
He has the idea of like having the old tree, the old state, and then the new one, and he compares both.
yeah.
It only goes as deep as it needs to.
Exactly. So this component could be really big. It doesn't want to have to re-render the whole thing every time. When I change email, it's only affecting a very small part of the UI. So React wants to be smart and only affect that part of the component. I'll look more into it, because I think that's also in the ideal case. There are things where like React can get sloppy and it just ends up re-rendering a lot of the component. But yeah, exactly. So it has it like a mental model of what the current UI looks like, and it takes your change and it compares it to what it looks like currently, and it says, okay, this thing will be affected, so let's only re-render that on our page. Yeah, but the other benefit to this is now we have both email and password accessible throughout our component very easily, just with email and password. So I have them just logged here when I do a login attempt. We now get login attempt and my two values that I had put in there. The next thing, we're going to need a couple more states. We'll have a new one called logged in, maybe, and we'll have set logged in. And by default, the user is not logged in. Yeah.
Just for clarification, so I know with the prevent default, if you were to take that out and you were to type, would it be tracking, like would it type out every keystroke on the console log?
So if we take that out, well, the prevent default's only for when I submit. So it doesn't have anything here, but when I submit, it does like a refresh, and then I get nothing. So we'll get rid of that. I don't have an application to attach this to, so I'm just going to write like a fake login function up here, but I'm going to try and simulate what a real login would be like. So a real login, I would take email and password. I'm also going to do a callback because I'm going to do this asynchronously. So given an email and password, I'm going to set a timeout. I'm going to pass down into the thing a callback function for when that timeout gets completed, and I'm going to do a timeout of, we'll just do 1 second. Once 1 second has passed, I'm going to do a check if the email that was passed in equals test, and I'm also going to check if the password equals password. So if I've given those two credentials, then I want to call the callback with my value true, meaning they are logged in. If they don't pass those two credentials, I want to return my callback with the value false. So this function isn't doing anything real, but it's simulating what a login would do. You would call some probably request given the password email. It would take time because it would be a request. And once the request returned, you would either use like callback or a promise or something and receive the result of your login attempt. So we're just passing the email and password. We only have one like real login, which is email test and password, and we'll return true if they hit that. So down in our login attempt thing, we can go actually no, we'll go login. We'll pass it the current email. Yeah, email and then password. And then the third parameter is a callback. And this returns whether they've logged in or not. So we can say success here. And in here, we will know whether they successfully logged in or not. So if success, then for now, we'll just console log logged in. Otherwise, we'll just console log wrong info. So if we type in just a random set of stuff, and I hit login, looks like we did.
Like you're running it, but you're not running it inside.
Sorry, what was the? So we have. Oh yeah. So this will be logging simulator. So we go this, hit login. Oh, we gotta have this first thing we do. So try again. And we get, I did it twice, but we first get the login attempt with what I did. Actually, let's do it again. Let's move this up. We'll be able to see it better. So what we'll see is right away we get a login attempt, and then after 1 second we get the response from my fake kind of HTTP request giving wrong info. But if I go test and password, I get login attempt, and then I get a successful logged in. So what I can do here is I can set logged in, if they're logged in, to true. And then I can also set logged in to false if they didn't log in. Although I probably could leave this because they're already not logged in. What we have though is for the user, when they do this, they kind of aren't getting nice feedback as to what's happening. So we can provide some feedback. The first thing we can maybe do is we can add a new check in here. We'll check if they're logged in. If they're logged in, then we want to show an H2 maybe, and we'll say you are logged in. So I don't know if you guys have seen this pattern, but I am doing it within the curly brackets. So it's JavaScript, and I'm doing a Boolean value, and then so a conditional, and then some JSX. What will happen is if I'm testing multiple conditions, the last real or last truthy condition will be outputted. So here, if I do logged in and this, if this is truthy and this is truthy, the second one will be outputted. If either of them is falsy, nothing will be outputted. If I did chained on a third one, if they're all three truthy, only this one would be outputted.
And that's done by the JSX.
That's like a JavaScript thing itself. So if I had a statement where I was like let test equal true and thing, test would equal thing. It's a way of doing inline.
I'm just looking at the
JavaScript, though.
like the header stuff.
Oh yeah, so this is like a JSX element. So now if I go test and password, it should set our value, and then we get you are logged in.
Because like what ends up happening within that curly bracket, where you're doing like the if and sort of thing,
Mhm.
it would be JSX, then converted to JavaScript, which would be the header 2 stuff with the stuff that puts out the header.
It would
Like,
be
I'm not good. I'm not explaining it probably, but like I get it. I'm just
okay. Well, I'm gonna go back through a lot of it at the end too, so we can kind of emphasize whatever's confusing. So I also want, if they're logged, this is like the reverse of what I did there, logged in, or I want to show all of this stuff. So I can go to the bottom of my form. So what I'm saying is, if they're logged in, good, just return true, which is like nothing in terms of HTML. Or if they're not logged in, then return all of this stuff. So now I have test, password, and then I get that. Oh no. The next thing we can add is if I get something wrong, it doesn't tell me anything, and that's not a nice login form. So let's create a new state const error and set error. And again, we're using state for all of this stuff. The default error message will just be nothing. Down here, maybe inside of our form, we will have a p tag. And inside of this p tag, we will just display our current error. So there's nothing, no error, so nothing's showing there. But if we get a unsuccessful login, which is this case here, we can go set error, and we can set it to wrong username or password. And then inversely, maybe we can set the error to nothing if they successfully log in. Now if I put a bunch of jumbles in there, hit login, I get wrong username or password, which is nice. The other thing, because it's taking time to send our login simulator and back, during this time before anything's shown, it's not really like, there's no feedback to me as a user. We could put a spinner. That might take a little bit of time, but we'll do something kind of simple for now. We'll add a new state called waiting, and then set waiting. We'll go use state. By default, we're not waiting, so we set it to false. And then here, right before we do our login simulator, so right before we do the async thing, we're going to go set waiting, and we want to set it to true. So as that request is taking place, our waiting state will be set to true. And then the second it returns to us, second that callback gets run, we're going to set it back to false. And then inside of our form, we can come into our input and we can say disable equals waiting. So if we're not waiting, disable will be false, and if we are waiting, it'll be true. So if I hit login, nope, disabled. Yeah, we get it like blurred out until the response comes back. Not like the best UI, but at least we have a little bit of feedback. Again, we could put like a spinner or something if we want to do this later. The other thing that I think might be nice would be if we put something in, maybe it gets cleared after it comes back. So we could also go into here, and on a unsuccessful login, we could go set email. We'll set it to nothing, and then we'll also go set password, and we'll set it to nothing. So when I go to that, it gets blanked out. One last thing. If I log in, currently I'm just logged in forever, so let's quickly add a logout button. So if I'm logged in, I want to display this. Maybe I also want to display a button on click. We'll do a function we haven't created yet called logout. And we'll call it logout. I'm missing something? Probably. Sorry? Out. And then here, so we'll go div, or we could use React fragment. There you go. So when this logout function gets called, what we want to do is we want to go set logged in and set that to false. Get a pretty simple function here. Okay, so let's have a run through of our functionality. We do wrong information, we get wrong username and password, and everything gets blanked out. We put the correct password and email in there. We get you are logged in, and we get a little logout that we can. Oh, so that's cool. Here we set logged in to false, like the word. So with our logged in and thing, this gets successful, and so we get it outputted. So instead, we want to set it to false. False.
You can't leave.
So now we can log out. Cool. So what do we notice looking at my code? First thing, we have this whole block of set states here, which is super messy. And then because of that, in our conditions, we have like a big, long set of us updating the state. I know you guys have already started to get around this kind of thing by having functions to control all of your different states and things like that. But this is a great opportunity for us to use a reducer. And what we can do is we can come up here and we can say maybe like login info and dispatch login info. And we're going to use reducer. We're going to pass it a reduce login info function that we don't have defined yet. And we're also going to pass it some initial login info. Yeah, there's one. I think it's just I need to define both of these. So we'll have our initial login info, and that's going to be, we want more complex state, so we're going to encapsulate all this information in one object where we have email, we have password, we have whether they're logged in or not. We have if there's an error, and then we also have waiting, which is default false. And then we also want to make a reduce login info, which is a reducer, so it's going to follow our pattern for reducers, which it will take in an action and state, and it's going to return some updated state. For now, we'll just return state as it is. So we have all of the same logic or same data encapsulated in a single state now. We could have done that with set state, of course. But this will make it easier for us to do. The next thing we can see is that we have two big cases, whether there's a successful login or a failed login. And what we want to do, instead of thinking of all of the individual pieces of data that we need to change into our state, we want to step back and think back to what are the user actions. Let's define a general user action and use the reducer to modify our state in a more like abstract or easier to understand way. So we can go dispatch login info. We'll pass it an object with a type. And the action that's happening here is logged in, I guess, or we'll just call it success. And then when they unsuccessfully log in, we can call the same thing, but our type will be fail. We don't necessarily have to pass in additional information because we do the same thing regardless of what username, or we just want to set logged into true, we want to set error, and so forth. So then in our reduce login info, we can handle these things. In this case, maybe we'll use a lookup. So we'll go login lookup. And we'll have the first thing in here be success, which we'll call a function given a state, I guess. We don't necessarily have to pass in anything else, again, because nothing different happens between successes. And we'll return, this is where we'll use one of those immutable data patterns that we started to see yesterday. We'll go spread of state, and then we'll just reset or overwrite any of the properties that we want to do. So in this case, when they log in, we want to set logged in to true. We want to set the error to blank. So we'll go logged in true, error blank. I'm also going to go waiting to true or false. So because before we were handling it in another way, I'll show in a second. And then we also want a fail function that takes in the state and returns something a little bit similar. But in our failure case down here, we want to set email, password, set the error. So we'll add that to ours. Logged in will be false. The error will be incorrect username, I guess it's email or password. And then we also want to go emails, nothing, password. So we can replace now this big kind of unseemly chunk with just that dispatch info type success. Same with this. We can get rid of this big unseemly chunk and erase that. And then we can look around and find the other cases where we're using our old set state. So here we're setting waiting. This is only a single call, but we can also just replace it. So and it's a new type called maybe wait. Success, fail, wait. Wait is probably like the simplest one. We just return the state and we set waiting to true. So now it's just a matter of like running around. This is like in Tiny App when they made you change everything halfway through and then you just get errors everywhere. Similar thing's going to happen to us. So I'm going to delete all of these, and then we'll start seeing the red. We don't need to set waiting to false anymore because I've handled that with a success or fail. I've turned off the waiting. Log out, we'll replace that one. New event to log out. It's a little tedious because we're doing everything kind of twice, but if we had, decided to do a reducer from the start, it wouldn't be the case, obviously. Okay. So now some of the main things are that we no longer have individual state properties for all of these. They're all part of our login info object. Do you guys know if trying to see if there are nice. So instead of that's not actually that nice. Whatever. Instead of email, we want to do login info.email, except for one of these, which was just text. And then instead of password,
I can't remember how you unselect, but I know you can.
we just won't worry about it. We'll go, what was it, login info? And then, so with this one, I think there's only 2 of those. Login info dot logged in. Login info dot error. Okay, we're gonna get through it. Set email. Okay, we still have set email, the set password, and waiting. Okay, so we don't have actions for these 2 right now. We could create an action for both of them if we wanted to. We could also kind of cheat and maybe do something like this, where we go dispatch event, and we create a generic event where we go type, we'll call it a set type, and then we pass it a key, and that will be email in this case. And then we also pass it a value, and that will be event.target .value. So in a real application, you probably wouldn't have a generic event like this, because now you can just set anything within the state however you want. Although, like, it depends on how secure you want your state to be. So in this case, we're going password. And then up here in our lookup, we now create another thing where we're going set. And this will have to take more parameters than state. We'll go state and what do we call it? Action. And based on our state and action, we're going to return an object, spread the state, and then dynamically we're going to get the action.key, and then also dynamically we're going to get the action.value. Oh, yeah, there you go. Okay. So there's one last thing. We are using a lookup, but where our lookup isn't connected to anything right now. So similar to when we used the lookup before, in our reducer, we have to return, what did we call it? Login lookup. We need to get the action.type from it, and then we are going to call whatever function is returned from the lookup with state, and we're like reversing our order of stuff, which is not nice, but we'll leave it. And the action. Save. We could also do that thing that we saw earlier where if it doesn't exist, so if that is falsy, then we'll just return state as it is. Maybe we're not going to get errors, but let's check. So right away, nothing's working. So what was this for? Why is it called logout? Should not do we need to call this? Oh, that's fine. Okay. So we have use reducer, reduce login info. Let's just console log the action so we see which actions are coming through. These ones are not. Oh, that might be because what's our value? Oh, and value is there. Looking for the email, dispatch event. Oh, dispatch event. No! That was the autocorrect thing. Oh man, they better not all be. There we go. Those ones are good. All right. So. What? Okay. Let's look up. We got.
You have a tree issue. Too many trees.
Okay, that's our lookup. Let's just simplify things. Okay. So our state, let's check that this is the action that's being called. So it seems like we're getting an error because our stuff's getting triggered multiple times. Email. So I'm console logging action and I'm getting what looks like state. So I've just mixed these up, I'm pretty sure. But maybe not. Let's. Okay. That looks right. See, that was when we were mixing these up. It affected us. Yeah, definitely. Because I can name those anything I want, right? Like here, reduce login info is getting called by my reducer because I'm passing it here, but it's giving me the values in a specific order. I could say like apple, watermelon. It doesn't care what I name them. It's just saying I'll give you the state as the first thing and the action as the second thing. But let's see. First I do the wrong action. I get incorrect email and password, and I had the blurred out thing. Then we do test and password. You get you're logged in, and we can log out. So, like the conclusion is not very exciting, but if we look at our code, this is like much cleaner, and especially if we're looking at our component itself, our component is like now like half as many lines of code, and that's where you really want to like kind of reduce the amount of code is within your component itself, so it's readable, so it's kind of like lightweight, and it still performs all the functions. It's 12 o'clock, but do you guys want to see some super quick sockets?
He's been prepping for this
Yeah,
socket thing for a long time, so
Yeah. If you guys were like, no, we hate sockets, I would just be.
Like, if anyone wants to like sit down for half an hour and just ask him about sockets.
So, oh jeez. So super quick, sockets are a way of doing real-time communication over the network. So with HTTP requests, the problem is that like I send a message to you, it's a single message. I mean, you give me a response, but after that, like we can't just ping back and forth. If you think of like chat applications, that's like the easiest. God, this isn't it. This is like the easiest example of. What do you call it? Of WebSockets that I can think of, but also other things. Like if you played IO games online, like Slither or Powerline, those are all WebSockets as well. So I have, what is it called? I have an application I made called LoudChat. It has both a client and a server. So I'm going to start the client right now. And then I think I already started the server over here. It's not this. But it's this. And it's just a basic chat application, but, so I say my name, and then I message.
What up?
But now everyone has to go, and we're going to go to, what is it under? No. Do you guys, system preferences, network. Okay, so I need you to go to this IP address, 192.168.88.134. Ooh, if you're going on your phones, get ready for maybe not some optimized UI. I definitely thought most people would be going on their computers, but I think it's 3,000. Let's see. I'm gonna see what it's gonna look like. Yeah, it's okay. Colon 3,000 didn't show up. 192.168.88.134. Is it working? Oh. Okay. Turn up your volumes, and then we need people also putting in their names and messages. Oh, sorry. The IP address is 192. Oh, how am I not connected? It's reconnecting. It's Lighthouse's fault. It's the same one, thankfully. 192.168.88.134. I'll zoom in. Port is 3,000. It might be, can you refresh it?
As if.
Oh no. No, I just forgot to update all of the. Oh, I can do it quickly. Okay. Bear with me. Bear with me.
It's gonna be worth it.
Yeah, it's gonna be worth it, guys.
Everyone's phone. All the things they have.
Okay, but this will be a learning experience. So the thing I didn't do was in my client side. So this is like the client application. I'm connecting to the WebSocket, but I have localhost :8080, and localhost works for me, but it doesn't work for any of you. So I have to do 192.1. What was it? 168.88. So I save that, and I'll check if it works for me.
As if.
Wait. Yes!
Oh my god. ASDM.
You. I am alive. Hello. Hello. Oh my god. Hey yo 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 yo. EICBEJCNSJX. The internet.
The other thing you'll notice is it gets a nice randomized Pokemon avatar for you every time you log in.
What the hell? Yen equals greater than percent euro greater than equals yen percent pound euro WOO. Feel so good. Hey Grav. I am the greatest. Face with tears of joy. Smiling face with sunglasses. Kissing face with closed eyes.
Kissing
Smiling
face with closed
sunglasses.
eyes.
Face with tears of joy. Smiling face with sunglasses. Kissing face with closed eyes. Black square. Black square. Black square. Black square. Black square. Black square. La la la. Unified ideograph. Unified ideograph. Unified ideograph. Unified ideograph. 8, 3, 73 inches. Plus yen, pound, equals greater than.
Nice contribution, Brian.
Unified ideograph. Unified ideograph.
All right. So we didn't go into sockets really, but I'll put my notes up. They have information on them. They're really fun and they're like not too hard to use. I'll also put a link to this project so you can look through the code a little bit. It's not too bad. It does use reducers because originally we were going to look at sockets with reducers. Yeah, also if you have any questions about it, let me know. I'm not sure.
This is worth it.
Nice.
The whole week you spend on sockets.
For this one moment. Cool. Yeah, thanks guys. I'll be around. Let me know if you have any other questions.
How about